Good afternoon, everybody. My name is Justin Glisan. I am the State Climatologist of Iowa for the Iowa Department of Agriculture and Land Stewardship, and it will be my pleasure to give this presentation this afternoon. So these webinars are an important service to the Central region, and it's a very collaborative effort with all of the those listed below the collaboration activity between. The next webinar will be January 17th, 2019, and the presenter will be announced at some point in the future. And these links show us previous webinars and information that you will find in this given webinar. And then, as Doug said, we'll have questions at the end. So generally,
one more thing. Hey, Justin, sorry, I told you I wasn't going to butt in on you, but I'm going to butt in on you. So here goes. I forgot to mention, at the end of the year or at the beginning of next year, whatever, I will reset the calendar for the webinars. If I do it right, those of you who are on here, those of you who have signed up, I should say, in the past, won't have to redo that. If I do it wrong, we'll have to re-sign up everybody for the webinar. So, wish me luck on doing that. But hopefully this will be seamless for all of you. But anyway, sorry about that, Justin. Go ahead.
No worries. Thank you. Okay, so getting back to the presentation outline, what we're going to do is we'll look at recent conditions such as temperature and precipitation ranks over the last month and year to date, 30-day temperature and precipitation maps, modeled soil moisture, stream flow, drought, snow, snowpack, snow water equivalent, Great Lakes, things like this. And then we'll go into actual statewide and regional impacts that we've seen over the past month. And then I'll get into outlooks such as the quote-unquote El Nino, short-term outlooks, and then some winter season information. So what we're going to look at first are recent conditions, and what this map up here shows are November temperature ranks, and these are statewide average temperature ranks across the United States. And looking across the region, we're seeing a similar trend from late September into October, with Montana and Wyoming being near average, while the remaining states in the region are, below average. Given the darker the blue, the more below average the state is. This is especially evident in the Midwest, with Kansas, Iowa, Missouri, Illinois much below average, with Missouri and Illinois being 4th and 9th respectively. These colder than average conditions have continued to cool the year-to-date trend that we see in this next slide, with Nebraska and South Dakota showing below average conditions. From last month, we see Missouri and Illinois cooling down to the near average category. Wyoming and the far eastern states continue to be at the above average, given their tone of red. So then we'll look at precipitation. And if we remember back to October, we had above average precipitation across much of the central region, with Iowa, Kansas, Wisconsin, and Michigan much above average. In November, we saw near average conditions with states on the east and west periphery of the central region above to much above average, looking at Ohio with 115. So the higher that number, the wetter the state is. The near average behavior in November effectively held down the year-to-date trend, or held the year-to-date trend in stasis. So not many states saw appreciable rank changes. Montana did go from near normal conditions to slightly above average. Throughout the year, we have seen an extended axis of anomalous wetness from eastern Nebraska through Iowa into Illinois, and this is reflected in the much above average conditions that we see in the central part of the United States, and then getting into the Great Lakes states. These really wet conditions have done well in improving significant drought conditions that we had in summer, and then moving through that wet autumn that we had in the Midwest. So now we're looking at a departure in temperature over the last 30 days. And you'll notice two two shapes on here, a line and the circle. The circle shows us that over the last 30 days, we've seen a pronounced axis. Okay, so this line in the central region dividing, slightly cooler than normal conditions from the warmer conditions to the left of that diagonal line. Namely, you look at this axis from effectively middle Minnesota to southwest Kansas. East of this line, temperatures have been up to 4 degrees below average. And then you look at, the Dakotas and then into Montana, where we're having temperatures over the last 30 days 6 to 8 degrees above normal. Pronounced warmness is also seen in Nebraska, and this is in stark contrast to the last part of October and November, where temperatures were unseasonably cool across the entire central region, if you remember that map from last webinar. In terms of 30-day precipitation, a very noticeable section of high percentage, 200 to 400% above normal precipitation across southern South Dakota into Nebraska, much of the state, and then into Kansas. Flanking these regions, if you look to the northeast and southwest, we have regions that are under 25% precipitation. That being said, the units here are in percentage, and we need to remember that it doesn't take a whole lot of water, especially this time of year, to flip these values to positive percentages. So now we are looking at a modeled soil moisture. And another way of looking at water in the system is the modeled soil moisture anomaly. And we haven't seen a lot of change from last month's presentation. What we do see is how much water is available below the surface, and the darker the blue, the more soil moisture is available. And on the flip side of that, the warmer the color, the anomaly is the dry anomaly. Anomalies are generally running from 50 to 100% positive. Nebraska, Kansas, Missouri. Where we do see negative anomalies are across Illinois into southwest Missouri, which is currently under abnormally dry conditions in terms of drought. One caveat for this modeled product, one caveat is that this is a model product, so it doesn't necessarily always get the full picture. We've had the story about a farmer being on a negative anomaly and having wet fields, so we always have to take that into consideration. And this slide is just the calculated moisture percentile. So what this shows us is how much soil moisture is available. The darker the green, the higher the percentile, so the more subsoil moisture is available. And you see the noticeable part in Colorado, where they're in D4 drought. They're in the top 1 percentile of dryness. So that's really being shown in the drought map that I'll show later. Looking across the central region, we do see basically percentiles above 70%, and then you get that really wet axis from eastern Nebraska through northern Iowa into Wisconsin, where the wet autumn and wet late summer really put down a lot of rain. Another way of looking at water in the system is stream flow, or the amount of water running off the surface or from groundwater sources into streams. This is a measure of how much water is moving through our system and river systems in general. The darker the dot, the higher the stream flow. East of the Missouri, we see conditions generally above normal, transitioning to near normal as we move into the eastern part of the region. We do find some below normal stream flow in southwest Missouri, getting into Nebraska, and then that D4 region in Colorado. So again, we look at a convergence of evidence in terms of drought in these stream flow and soil moisture anomalies give us a good indication of wetness or dryness. Looking here, we have the Central Region drought map. 1 month ago, we have the top left valid November 13th, and then to the right, we have the new drought monitor map that was issued this morning and valid on Tuesday. There isn't a lot of change between the last month. If you look at the plot on the bottom, we do see some 1 to 2 class degradations in southwest Missouri. And then along the border into Kansas, those are shown in the warmer colors. If you look at Montana, North Dakota, South Dakota, even in Colorado, where we have those green colors, those are 1 class improvements from what we saw last month. So getting into a season where it's getting into the dry season, but it's easier for rainfall and things like that to ease drought conditions given this time of year. And again, I want to highlight this D4 region, and it's effectively in stasis right now. Okay, so now the next figure that we have here is modeled snow depth as of this morning. And what we can see is we have in the western part of the domain, we see the snowpack in the mountains. And then moving into Nebraska, southern Minnesota, northern Iowa, we see snowpack that was from the blizzard over Thanksgiving weekend, and then some other transient systems that have moved through the United States. But as you'll see in the impact section, we've had some places in the central region with record snowfall in the month and this time of year. So speaking of snow, now what we'll look at is what we call snow water equivalent percent of normal. So what you're looking at is a map of the western United States and individual watersheds that feed into larger watersheds like the Missouri River Basin. What these colors are showing us and these numbers are showing us are the equivalent snow water in existence currently based on the 30-year median. So as we transition from west to east, we notice that we're getting into basins that are above 100%, especially in eastern Colorado, Wyoming. And then we're starting to transition to generally above 70% of the 30-year median. Now, we're still early enough in the season where we can build up the snowpack. The basins draining into the Missouri are generally 70% and above. And as you can see, as I pointed out, that those bluer colors indicate snowpack water equivalent above 100%. So this we'll have to look at in terms of the soil moisture anomalies also, because when we get into the growing season or springtime, this will affect river levels as the snowpack melts. So this figure here is the Missouri River Basin, and so this is kind of a function of what we just saw. But generally what we're seeing here is total above Fort Peck, and then to the right, Fort Peck to Garrison. The snowpack water content is running below average for this time of year, 76% of the December 17th average for above Fort Peck, 86% of the average for Fort Peck to Garrison. That being said, there's still time to catch up as we're only 1/3 of the way into the accumulation period. The next slide is similar to what we saw in the previous slide, but we're looking at the Platte River Basin. And as you can see here, the total North Platte and total South Platte are running above average for this time of year. So 103% for North Platte, 104% of average for the South Platte Basin. And then we look at the Missouri River. So Missouri River main stem reservoir status, and this is as of December 17th. 2018 will be the third highest runoff year for the upper Missouri River Basin, only behind 1997 and 2011. And if you look on the plot, you notice that the 2011 year is that black line, and then 2018 is the current system storage. So as you can see, the red line has crossed under the 2011 record, and this is a trend that we've seen since November. Projected releases will be above average through November into December to evacuate the bulk of water that's been stored and before reducing into the winter releases. And then we'll look at Great Lake levels. All the Great Lakes are running above their long-term averages, as you can see with that red line on the plot. Lake Superior, Michigan, Huron, and Erie are near last year's level. And then Lake Ontario is a tad lower than the same time last year. And forecasted levels over the next 6 months should remain above the 100-year, so 1918 to 2018 long-term average. And here, this plot conveys two messages. One, the actual surface temperature of the water of each of the Great Lakes, and then also median ice concentration. So given this time of year, we're starting to get into the cold season, but the lake temperatures are generally above freezing. Now we do see some snowpack or ice concentration in Lake Superior, getting down into Huron and then near Green Bay, but we'll start to see more lake freeze as we move into the cold season. Here is it's a nice plot showing the percent coverage of the Great Lakes, and it's the annual maximum ice coverage from 1973 through 2018. Now looking at the current year at 69%, we're slightly behind last year at this time, but again, there's plenty of time in the season for freeze up of these lakes. And now we transition into looking at precipitation. So as you all know, we've had an extremely wet year in the Midwest, especially the axis from northern Iowa through into Wisconsin, in some parts of Minnesota. And then you have a secondary axis from St. Louis to, around Pittsburgh, so getting into Ohio. What these pins are indicating are record precipitation, year-to-date precipitation records. So all of these stations have broken their all-time records. So these really convey that it's been an extremely wet year in parts of the United States. So now we'll get into state impacts that have been of note recently. The first one we'll talk about is snowfall totals. So we've had unseasonably high snowfall totals for November across Iowa, Kansas, Nebraska, Michigan, Missouri. Many locations across southeast and south central Nebraska have already received over 50% of their annual seasonal average snowfall by the end of November. Stations along the Kansas border have already exceeded last year's snow total. So these are some cities: Concordia, Kansas, Topeka, Kansas, coming in at second and fourth snowiest. Lincoln, Nebraska, and Grand Island, Nebraska, 7th and 10th snowiest. And we're not even into wintertime yet. So these are really telling about how the snow systems have moved through the Midwest early in the season. Next of interest was the Illinois tornado outbreak on December 1st. And if you'll remember, this is a week after blizzard conditions moved through the state. So I believe there were 29 confirmed tornadoes, and this is the largest outbreak in December for Illinois. And as you can see, there are, various ratings for the tornadoes, but we do have a track of EF3 just west and north of Taylorville. And then we have some other EF1, EF2 damage across that part of the state. But it was very interesting moving from blizzard conditions to tornadic conditions. So a very active cycle with a lot of energy in the system. And then another thing of note, especially in the agricultural states, are soybean harvest. So 2018 is now the slowest harvest over the 1995 to 2018 period. Looking at the rankings, you look at 2018, 94% of harvest was reached at November 25th. This is ahead of 1996 and 2009. Some fields across the region remain unharvested, Iowa, Indiana, Michigan, Nebraska, Ohio. And this also gets into corn. Corn can stay in the field longer and be harvested in the spring if needed. Soybeans are more temperamental, so you get into moisture, quality issues. A lot of the soybeans have been binned due to low commodity prices, as I said, moisture dockage, and quality issues. And this is especially prevalent in Indiana, Nebraska, Ohio, and a little bit in Iowa. Looking at Kansas, the wheat crop, extremely wet conditions across the fall season in Kansas have really impacted when farmers have planted their wheat. So if you look at the picture here, the sowing date on the left is the 20th of September, middle is 20th of October, and then the right-hand side is sowing date of November 5th. You can see a huge difference between mid-September into November. So the extremely wet fall conditions, Kansas, it was 7th wettest at almost 4 inches above normal. Only 65% of the wheat crop has been planted late, And reports from the field indicate more acres will not be planted with wheat because of the wet conditions. And there have been discussions in Kansas about planting spring wheat while keeping crop rotation intact, so going through the same crop rotation that you would normally do if you planted winter wheat. Another note in November was this Ohio-Kentucky ice storm, and this occurred between November 14th and 15th, southwest Iowa into northern Kentucky, where areas saw between a quarter inch up to 0.4 inches of accretion. And you can look at the first image, the standard CocoRa's 4-inch rain gauge just coated in ice, and then the rows covered in ice above it. This was extremely unusual November weather. The ice storm created downed trees and power lines, causing widespread power outages, especially in Lexington, Kentucky, where they had 19 outages over that period of time. Murray State University canceled classes at 6 campuses. And as you know, universities typically do not cancel classes unless conditions are dire. And then we also had some sustained and significant ice damage at the Boone County Arboretum, and this is in southwest of Cincinnati. Half of over their 3,600 trees and shrubs experienced damage, and unfortunately 10 to 15% was severe damage. And then we had the good old Thanksgiving blizzard across Kansas, Iowa, Illinois, and northern Missouri. In our region, portions of Interstate 35 in Kansas, 70 Colorado into Kansas, and I-80 Wyoming, Nebraska into Iowa were closed due to these blizzard conditions. The governor of Kansas declared states of emergency at the University of Kansas, and UMKC canceled classes that Monday after Thanksgiving because of conditions on the ground. Osceola, Iowa reported 12 inches of snow and 45-mile-per-hour wind gusts. I believe the top wind gust reported in Iowa was 57 miles per hour. Kansas City Metro had peak winds of 56 miles per hour. And as you can see on the right figure here, the gradient between the I-80 corridor south was about 10 miles between a trace of snow that we had here in Des Moines versus 10 miles south where 8 inches was on the ground. So it was a very tight gradient of snowfall with this powerful system. And then more generally, we've had wetness issues across the central region. Cattle feedlots have been battling mud, which has a very big impact on feeding operations. And this was prevalent in Nebraska, Kansas, Iowa, Illinois, and Indiana. Given the wet and muddy conditions, any additional moisture will not soak into the already saturated soil. And then wet pastures and the muddiness in those pastures are keeping cattle inside barns where feeding operations have to be moved to. And many farmers have been granted extensions past the December 10th crop insurance reporting deadline as a result of the very wet autumn conditions and the slow harvest that was caused by these really wet conditions, especially in Nebraska, Iowa, and Kansas. So now we're going to look at some information on El Nino into 2018-2019, the quote-unquote El Nino that we'll discuss a little. And of note here, I just wanted to point out that the Midwest, Great Lakes, and Missouri River Basin all have these nice two-pagers for El Nino impacts and outlooks. So I've included the links to these, and they're very instructive and good for stakeholders across the central region. So we're currently in an El Nino watch. We're at a 90% chance of formation through Northern Hemisphere winter and a 60% chance of continuation through the spring. We're seeing ENSO neutral conditions continue during November and into December, despite the continuation of the above average sea surface temperatures in the Nino regions in the Pacific. And why we're not seeing an active El Nino signal is because the atmospheric anomalies are largely reflected intra-seasonal variability related to the Madden-Julian oscillation, and I won't get into the technical aspect of that. But we haven't had a coupling of the atmosphere to the sea surface temperatures yet, so we haven't really seen El Nino form. But we're expecting a weak formation into next month. So here we have the CPC, Climate Prediction Center, official probabilistic El Nino Southern Oscillation forecast. And again, what we're seeing as you move from left to right, these are seasonal, so November, December, January, February into the spring. We do see high confidence of El Nino forecast, of the El Nino forecast probability occurring, and it's tailing off as we get into the spring season. So now we'll look at climate outlooks, short-term, long-term. So we'll look at 7-day quantitative precipitation forecast, the hazard outlooks, the near-term 6 to 10-day outlook. We'll talk a little bit about holiday storm systems, January temperature, precipitation, and then some seasonal forecasts. Right now, 7-day quantitative precipitation forecast shows, and this is valid 20 December through the 27th of December, it does show an above average possibility of above average precipitation, snow and rainfall, given the track of the low that I'll talk about a little later. But we are seeing in the central part of the United States a good shot at having precipitation that could impact and probably will impact holiday travel between Christmas and New Year's. This 3 to 7 day hazard outlook put out by the National Weather Service is also a great indicator of regions in which will be impacted by some sort of hazardous weather. What we're seeing here across the central region, and if you look at this teal blue line, heavy snowfall. So you see, as we track from the Pacific Northwest all the way through the central United States, this is the track of the system that will be coming through the United States late Christmas Day into the week of New Year's. And it's really outlining the possibility of heavy snow, which will impact regions north of Missouri, and then the possibility of heavy rainfall south of that region. This really meshes with the 6 to 10 day outlook, which is valid from Christmas Day, the 25th, through December 29th. So what we're seeing generally across the central region is west of the Dakotas, near normal, so EC to below normal, getting into Montana and Wyoming and Colorado. And then we look at the east part of the domain, much above average chances of above average temperature. We couple this with that bullseye of wetness in eastern Kansas, getting into parts of Missouri, Nebraska. What we're seeing here is a high probability of above average precipitation during next week, which will really have an impact on holiday travel. And then our concerns with the winter weather, I just wanted to show a plot. This is of GFS, so a model output of the possible snow track, and this is given the typical 10-to-1 ratio. 10 inches of snow would equal 1 inch of melted water. Again, it's early enough and the system is still way far away that the eventual amounts and locations will be determined later, but we do have a strong signal for heavy snow. There's a lot of precipitable water available in the atmosphere, and we have anomalous flow from the Gulf of Mexico into the central region. So this is something that we will really have to look at, and we may have to watch for leading edge freezing rain, sleet on the nose of this warm conveyor belt that is feeding warm, moist air into the system. So again, the story here is the track of the low will really determine who gets snow, how much snow, and who gets rain, and where that rainfall will occur. So getting to wrap things up, this January outlook is effectively EC over much of the central region, so equal chances of above or below average temperatures. Getting into the Dakotas, Montana, Wyoming, and Colorado, we have a slight chance of above average temperatures. Looking at precipitation, we have the dry bullseye over Indiana into Illinois, southern Michigan, Ohio, Kentucky, and then equal chance across the rest of the central region for above or below average precipitation. This set of plots, the top plots are January, February, March. The bottom plots are April, May, June. So it's getting a little further out there, but I just wanted to highlight some patterns that we're seeing. Again, we're kind of seeing above average chances of higher temperatures in the western part of the central region, northern part, Wisconsin, Minnesota, the Dakotas, whereas precipitation-wise in the winter season, we're seeing, again, that bullseye of dryness, Great Lakes states, Illinois, Indiana. Getting into April, May, June, we're effectively wedged between areas of above average probability of temperatures. So much of the region is equal chance of above or below average. What we're getting in the precipitation signal, though, is above average precipitation probabilities for getting into the growing season. And then one final plot here is the seasonal drought outlook. And what we see is just small sections of Missouri and then North Dakota, Colorado, and Montana having drought persist. And looking at Colorado, especially that D4 region, we're looking for some improvement in that northern part of that region, but still persistent in the region of most extensive drought. So the outlook summary, we have a 90% chance of a weak El Nino formation through northern hemisphere wintertime and 60% chance of continuation through spring of 2019. We have a possibility of a significant winter storm moving through the central region between Christmas Day and New Year's. January, equal chance of above or below average temperatures in the middle of the region with warmer than average into the Dakotas and Montana. dry bullseye over Indiana, as I indicated, and EC over the rest of the central region. And then of course, I forgot wintertime. But the signal that we're getting now is effectively what we're seeing in January. And again, this will be moderated by the formation of the weak El Nino. Okay, so in the interest of getting to questions, all of these presentations are recorded, and then all of these websites are where we get our information. So a very extensive collaboration that we have. And with that, I will thank you, and I will take questions, or questions can be presented.
Yep. Well, thank you very much, Justin. Just a couple of things. The patterns that we see, could you go back to the seasonal outlooks for January, February, March? Yeah, so the top two, just so everybody understands this, the top two maps here are 3-month period sort of anomalous temperature and precipitation patterns, and there's a probabilities, hedging probabilities if it's kind of brown and red colored towards warmer than normal, and where it's very light, there's a very sort of low confidence as opposed to dark red like on the West Coast, where it's a much higher confidence of above normal temperatures. Similar with the colors when it comes to precipitation as well. So I want to make sure everybody understands that. And the green obviously is for above normal precipitation in that area. These reflect, if you will, a more or less an El Nino pattern, even though, as Justin said, we're not in an official, they're not calling it an El Nino right now. They haven't gone to an advisory level. It's still on a watch. And I think he also alluded to the fact that this year is not behaving very well, or this El Nino is not behaving very well in the Pacific in terms of the ocean is behaving, but the atmosphere isn't sort of taking on the characteristics of an El Nino. Thus, if the atmosphere doesn't take on the characteristics, it doesn't necessarily get transported. The effects of it don't get necessarily transported to the northern hemisphere, and thus affect our weather and climate on a seasonal basis. There's something else. Okay, so we had a bunch of questions in here.
Hey, Doug, can I chime in one more thing while you're here? You're right about the probabilities being.
Is that you, Dennis? Is that you, Dennis Toddy?
Yeah.
Dennis, is that you?
Yes.
Okay, thank you.
But the slightly increased chance of precipitation in April, May, June is, while it's not a big chance, it does increase our probability for wetness problems, especially over the wetter areas from this last fall. Even though the probabilities are not big, we're already wet, so any chance of additional wetness is a problem.
Right, and maybe even normal, depending upon how it falls over a 3-month period, could be an issue. So we have a bunch of questions here. I'm going to kind of skip around here. One of the questions is, what does EC mean on these maps? And really, EC does not mean normal. It really means, again, it's sort of a, if you will, a little bit of a, there's not a lot to base an anomaly on in terms of being above or below. So what they're saying there, EC stands for equal chances. And really it's an equal chances for below, above, or near normal. All three of those things are in play there. So that's what EC stands for. It doesn't necessarily stand for normal. It really stands for it could go one of three ways. Any concerns about the lack of snow in the north central plains? Will that negatively impact soil conditions in the spring without significant snowfall? And I'm getting feedback from a speaker I'm hearing in the background. Is that you, Dennis? It's some speaker or something. At this point, can you go to the drought map real quick? And maybe anybody have any comments on either Dennis or Justin on any worries about the lack of snowfall? I think there are some drought concerns already in North Dakota, obviously. So yeah, I suppose if they don't develop a snowpack up there over the next few months, that could be an issue.
The lack of snowpack is really only a major issue for winter wheat, for the winter wheat areas, and that's more down in Nebraska and South Dakota because they like to have winter wheat covered when the cold comes around. The bigger areas, the bigger chances for snowfall in these areas tend to be late winter, early spring anyway. So the lack of snowfall right now is not a major issue. The better opportunities for bigger snowfalls are later on anyway.
Yeah, and even though we've been cooler than normal October and November, most of October anyway, and all of November, and recently warmed up, those temperatures aren't the Arctic types of temperatures that we see that commonly freeze the ground really deep into the winter and such. Brings me back to the next question, which is going to be kind of a long answer, but what is the role of the Madden-Julian oscillation, also called the MJO? We're going to get into a little discussion on this, playing in the current winter conditions for the North Central Plains. And the current conditions of the MJO, which is something that climatologists who do forecasting track, and it's an important player in the system. And it is also a tropical disturbance, if you will, that sort of goes around the Earth from west to east around the equator. However, it also has impacts into the northern hemisphere and thus affects our weather. And currently, there is a fairly, as they say, robust MJO, or a Madison-Julian oscillation, happening across the maritime continent, and that's supposedly moving. Well, that will affect us. The theory is it will affect us in January, mid to late January. And if it does, that energy will cause, if everything falls where it should, which it almost never does, but if it does, it should cause the likelihood of colder than normal conditions in the eastern two-thirds or half, if you will, of the United States. We'll have to see if that happens. It's not uncommon at all. I mean, it is January. We usually have at least 2 or 3 major Arctic outbreaks. It's not unheard of. We'll have to wait and see if that happens. Bryce also mentions that there's a discussion of stratospheric warming event, and I won't go into that because that gets even deeper into sort of climatological, I don't know. Dennis, help me out here. Do we want to talk about stratospheric warming and polar vortexes?
No. I guess Justin, no, let's not go that path.
Okay, it basically couples with the whole Madison-Julian oscillation idea of disturbing the weather in such a manner that it allows Arctic air to spill south. Okay, again, nothing unusual, fairly common in our winters. The fact that we haven't been seeing as many, the trend has seen less of those over time. Shouldn't be surprising to anybody, but if it's a typical year, we tend to get several of those, or a few of those, during our winter season. Can you define the snow forecast area a little tighter? Oh, so Bryce, I'm assuming you're talking about, in this case, I'm assuming you're talking about next week, and the answer is no. I wouldn't want to go out on a limb yet to say where it's going to snow and where it's not going to snow. The map that, can you go back to that forecast map with the snow, Justin? Next week's snow, the model output. Yeah. So I know everybody's going to be traveling. So this is just sort of a heads up. Like, it looks like it's going to snow out there, and it looks like it's going to start in Colorado and sort of go northeast somewhere across the U.S. This is going to change. This is not going to be the final or anything. It could be the final answer, but most likely this thing will be 200 miles north or south of this. I don't know how much freezing rain or ice and snow and all that kind of stuff people are be going to get. We know there's going to be a big storm. We know it's going to be impactful. I would say watch your local, either local media or your local National Weather Service forecast at weather.gov, and you can pinpoint the storm as it goes. Hard to plan on this right now, but I personally wouldn't want to be traveling, but I will be during that time in Nebraska. So I will be watching it. If there's any other questions you want based on that, Bryce, feel free to type them in. Where's the significant snowstorm expected to hit between Christmas? Okay, yeah. So I just sort of went over that, and I would say that the other map. Can you show the hazards map this time, Justin? I think that was further. Yeah, there he goes. That's our best guess right now. That blue area, the Front Range on Christmas Day, and then that moves out. We call that a classic Colorado low, and it moves out over the plains, the low pressure system, and to the north of the low pressure system, you get the heavy snows, potentially blizzard conditions if there's enough wind and cold. This system in and of itself isn't extremely cold. This is not the Arctic air. As far as I understand it, that's going to be drawn down into the system, but it's wintertime, so it's cold enough to snow, obviously. There's also plenty of moisture coming out of the Gulf. Also, as Justin said, you can see that heavy rain area sort of to the east and south of the heavy snow area. So that's our best guess. Dennis or Justin on that? Anybody want to say anything about the storm?
No, I think you got it.
And then Bryce gets into the polar vortex, strong cold wave moving into the interior. Yeah, later in January, Bryce, on that. Did you comment on the potential field work? Okay, yeah, this is more of your two guys' line here. Comment on potential field work issues to be extensively delayed next spring. Dennis, do you want
to? Yeah, that's what I was kind of hinting at right before we started down the questions, was that areas, certainly that area that Justin was showing in the very wet soil, the most wet soil conditions, we have some level of risk already, even without too much more rainfall, because we have very wet soils. If we get into a point, yeah, there we go. So that area all the way from Kansas, Nebraska, into southern Wisconsin is at some level of risk. Probably the northern area of Iowa, the biggest level of risk. If you lay the outlook for spring precipitation on, which leans a little bit towards the wet side, and our overall trend in springs in this area is toward the wet side too, much of that area could have real problems with getting out and getting field work done, because
maybe both of you guys talk a little bit more also on how that equates to or is parallel to those wet feed yards that people are seeing. I grew up on a feedlot, and I know what a pain it is for livestock as well as the actual farmer to deal with that, and we're seeing major issues like people reported to us from Kentucky, Ohio, and then of course across Iowa and other places. Now that will freeze up eventually, but anything you want to say about the issues with that?
Well, I mean, any precipitation that does fall is not going to be absorbed in the soil, so the conditions will just get muddier until there is freeze. So I mean, it's kind of a sponge that's already too soaked.
And areas further north do have some potential, as we will probably eventually turn colder somewhere along the way, to freeze up some of the feedlot areas. That will improve somewhat. But it not only is an issue for servicing and working with these livestock, it can become a health issue at some point too. Yeah. So it's not a pleasant situation, and can be a loss potentially.
Yeah, this year you saw the Missouri River's third highest runoff in the upper Missouri Basin, which and then you see all of this. We're just looking at soil moisture right now, but that's a fairly good indication of how wet the lower 48, let's say west of the Rockies, is. And I don't know. I'm trying to remember when I've seen it this wet before. It's pretty darn wet. It's a good point. Larry Ruthie brings up one of the National Weather Service folks makes a point of saying there could be a pretty good freezing rain area that is not indicated on the hazards map that we showed up there. That will be very much worth watching. But as he also says, we can't define that quite yet. So stay tuned to your media folks in the Weather Service. Any thoughts on jet stream locations over the winter and into April and May? So, if El Nino appears and starts reacting with the atmosphere, and when we get a typical El Nino, which I'm not sure what that is anymore, El Ninos often have a split jet stream, whereas you have a fairly robust subtropical jet stream across the southern part of the U.S., which brings storms and rain and clouds and that kind of thing. South, let's say the southern tier or two of states, where, again, in a normal sort of moderate, sometimes strong El Nino, you'll see another jet stream to the north of the U.S., and that usually contains some of the colder air further to the north, thus leaving that area between the southern U.S. and Canada relatively warm. And I guess I won't say much about precipitation because that can still happen. But typical areas of dryness are the Great Lakes and Ohio Basin in a typical El Nino, which I think is in the forecast, and portions of the northwest into western Montana, and portions of the upper Missouri Basin, as a matter of fact. So that would be a typical El Nino signature, and we'll have to see if that plays out. I mean, this is a tough one this year with what we have to work with. Then a good comment from the Corps about the flooding could result in flooding in the spring where ground is so wet. Yeah, so that's absolutely right. Where it's so wet, there's better chances, even with normal rainfall, to get sort of nuisance flooding or, if you will, minor or moderate flooding. But it's again much too early for us to go out on a limb and say it's gonna be a bad year next spring or summer because of what we're seeing right now. Just too much can happen in so many places. So we'll have to see how it plays out. Justin, any other comments you'd like to make? That's our last comment question.
I don't think so. I think we pretty much covered everything that was important.
Okay, Dennis?
Yeah, I think we touched on the concern I have is spring field work, spring flooding potential. Again, we're not saying it's going to happen, but it's a decent possibility, and we'll talk more about it the next couple of months, a couple of webinars.
Right. Yeah, and just one last comment. I guess we're getting, and this is something I certainly saw in driving to Omaha and Lincoln over, the last 6 months, is that due to the high runoff and due to the very heavy rains in southeast South Dakota, Iowa, Nebraska, the Missouri River stayed very high, plus the snowpack evacuation of the reservoirs to get them down to the right levels really caused a high water level in the Missouri River Basin, and not Missouri Basin, but the floodplain. And as Stuart's pointing out, there are a lot of crops still to be harvested down there, or in there, if they ever get harvested at all. because of the mud and the water standing. So it's not a great year in that neck of the woods, so to speak. So anyway, thank you everybody for your comments and input. Appreciate everyone being on here at this time of the season, and everybody, I hope, has a great holiday season. Thank you, and we will see you again in January. And I won't say let it snow. I know that's kind of a touchy thing to say at this point, but that's up to you guys. Have a Merry Christmas and Happy New Year. Talk to you all later.
You too.
And thank you, Justin.